Term 2 focused informal practice questions, grade 12 advanced. Which of the following is a correctly named alkene? In naming alkene, we always have to select the longest main chain containing the double bond. And the double bond, when we name it, we have to identify a number specifying the correct location of the double bond on the main chain. Now, looking at the options here, first one is not a correct answer because it is not an alkene. It ends with butane, ane. Now option B, it says 3-butene. We'll have to check and draw this one. C is definitely a wrong answer because there are two numbers. One number is specifying the location of the double bond, and one number is usually for a branch, and a branch cannot be on the first carbon. So the answer could be B or D. If we draw butene, 4 carbons, and number 3, so 1, 2, 3, here's the double bond. This is wrong because when I want to name this compound, I'll start counting from the side that is closer to the double bond. I'm sorry, I placed triple bond. So I will count from the side that is closer to the double bond. So therefore, 1-butene is a correctly named alkene because they started counting from the correct side. Name the alkene shown below. So, first of all, you have to select the longest main parent chain containing the double bond. Then you identify the branches that you have. Now, when naming alkenes, the priority in numbering goes for the side that is closer to the double bond. So in this case, we are going to count from the left. 1, 2, 3, 4, 5, 6, and 7. So 7 is a heptene. Heptene. Ene because there's a double bond. Now, where is this double bond? It's on the second carbon. So I will say 2-heptene. Then on the 4th and on the 6th, I have the same branch. Each one is a methyl because it has 1 carbon. So I have 4 and 6 dimethyl 2-heptene. You are given a branch chain alkene that contains 1 double bond and 2 branches. Alkyl group. From the YL, I know that it's saying that we have 2 branches. It doesn't say that the branch is made up of 2 carbons. We simply have 2 branches. So let's look at this one. I am putting an X on the carbons of the main chain. And here is the branch, and here's the second branch. Now this is an alkene, so I must find in this main chain a double bond. And here's the location of the double bond. So now, the closer side to the double bond is the left. So the longest continuous carbon chain that includes the double bond contains 7 carbons. 1, 2, 3, 4, 5, 6, and 7. The name of that parent chain is hept because it's 7 carbon. Then ene because it has a double bond, and you must write the number of the ene. It's on the second carbon. So you must write 2-heptene. There are substituents. Substituents is another name for branches. Substituents. So there are 1, 2 branches. It's already mentioned in the question. Each one is named methyl because each one is made up of 1 carbon. So I have a methyl on the 4th and on the 6th. So each one of them is named methyl. Now part B, give the IUPAC name of the above alkene. So let me just place the numbers correctly. 1, 2, 3, 4, 5, 6, and 7. So the final name is heptene on the second carbon. Then on the fourth and on the sixth carbon, I have methyl. Since both branches have the same name, instead of writing methyl twice, I'll write dimethyl. Moving on with the questions. Name the alkyne. Y and E means that I have triple bond. And draw the branched alkene. So first, let's name this one. Here is the main chain. And this main chain is mainly made up of 4 carbons. So it's a bute. Now this bute, it has 4 carbons and there's a triple bond closer to carbon number 1. So it is 1-butyne, no branches. Now to draw, okay, I'm gonna write 1-butyne down here to give myself more space to draw this chain, this compound. So I have here hept, means I have 7 carbons. So first I'll start drawing 7 carbons. 5, 6, and 7. So 1, 2, 3, 4, 5, 6, and 7. Now this heptene, on the third carbon, I have double bond. So 1, 2, 3. Here's a double bond. All the other bonds are single bonds. Now on the fifth carbon, which is this one, I have one branch that is made up of 1 carbon. Always in the exam, remember when you are drawing, after you finish the skeleton, you have to fill it with correct number of hydrogens. Every carbon will form 4 bonds. So, like for example, this carbon is making 2 bonds from right and left, and there will be 2 more hydrogens remaining to continue the octet rule of carbon. Here, hydrogens. This carbon has 1, 2, 3 bonds, and here's the 4th. Same thing for this one. This one will have 2 hydrogens, and the last one will have 3 hydrogens. And here we go. This is the main formula, the structural formula of 5-methyl-3-heptene. Moving on with the questions. Choose from compounds X, Y, and Z an alkene and alkyne. Alkene must have a double bond. Alkyne must have triple bond. So here's the alkene and here's the alkyne. So compound X is the alkyne, compound Y is the alkene. Now, next question, name or write or draw the formula. So the first example is given here. Here's the main chain, and this is a branch. Always we choose the longest possible main chain containing the double or the triple bond. And we start numbering from the side that is closer to the double bond. If I started numbering from this side, the double bond will come on the second carbon. So the ene is on the second carbon, and the branch is on the third. Now if I count from the other side, like 1, 2, 3, and 4, I will get also the double bond on the ene, but this time the branch will also be on the second carbon. So taking this side is much better. So the priority is for the double bond, and the second priority is to have a lower number for the branches. So having double bond on the second carbon is will be taken from the left side, because also on this side we will get a branch on a lower carbon as well. So the final name is bute, because I have 4 carbons. So 1, 2, 3, 4. And then I have ene on the second carbon. And then I have a branch of 1 carbon, and 1 carbon will be called methyl on the second carbon as well. Next, to draw 2,4-dimethyl 1-octene. So first I'll start drawing oct, which is 8 carbons. 1, 3, 4, 5, 6, 7, 8. On these 8 carbons, I have a double bond on the first carbon. So this is a double bond, and the rest of the bonds are single covalent bonds. Also on the second and on the fourth, on each one of them, I have 1 carbon branch, because the name is here is methyl. Now I'm done with the skeleton form. I will complete the bonds with hydrogens. Do not forget this step. This is a very common mistake for students. They always forget to draw the hydrogens. You can also write the hydrogens like that instead of spreading them. This carbon will not take any more hydrogens because it already has 4 bonds. Okay, so that's it. Now next, I start from the double bond. Here's the main chain made up of 1, 2, 3, 4 carbons. So that's a bute. And on the first carbon, I have the double bond, butene. And on the second carbon, I have a branch made up of 2 carbons, which is ethyl. So 2 ethyl, 1 butene. Moving on with the questions. Isomers. Subtopic 3.4 is about isomers. Always when you have different compounds, always double check the formula. Count the carbons and count the hydrogens. This is pentane, so it means I have 5 carbons and 12 hydrogens. You can also count them. To methylbutane, I also have 4 carbons as a main chain and 1 carbon branch, so the total is 5 C5H12. And to dimethyl propane means I have 3 carbons and I have 2 branches, each one carbon, so that makes it C5H12. So these 3 compounds, they have the same molecular formula, but the arrangement or the structure is different. And structural isomers, the atoms are bonded in a different way. And I can know that from the name as well. The name is different and the formula is the same. So which of the following best describe the relationship between the 3 compounds down here? So these are isomers. Now to be more specific, these are structural isomers, not geometric isomers. Geometric isomers, we need a double bond to talk about geometric isomers. So next, which of the statement is true? So first, let me look at the compounds. 1, 2, 3, 4, H10, 1, 2, 3, 4, H10, but these 2 are definitely isomers because this is a butane and this is a methylpropane, the second one. Now this one is not an isomer with them because I see a double bond over here. So 1, 2, 3, 4, H8. Anyway, this is a butene. So X and Y are structural isomers. That's it. Next question. Identify the type of isomers. The type of isomers could be geometrical or structural or not isomers. Yani the compounds would be identical. So let's first look at the first example. Here's the double bond. I have two large groups facing each other and two small groups also facing each other. So this is a structure of cis, and here I have the large groups away from each other and the small groups away from each other. So this is the structure of trans. So these two compounds for each other are considered geometrical isomers. Moving on, I have here C4H10 and here as well C4H10. So these are simply structural isomers. Structural isomers. No double bond. Now again here I have a double bond and I have the hydrogens or the small groups facing each other, while here they are opposite to each other. So this is a trans, this is a cis, and these two for each other are geometric isomers. Next, draw. There's a lot of drawing questions in this focused question document, so expect a lot of drawing in the exam. Draw 4 structural isomers. You need to draw isomers for 2-pentene and name each one. So first of all, 2-pentene. Here's the 2-pentene. 1, 2, 3, 4, and 5. So you cannot draw 2-pentene anymore and take it as an isomer. And the pent is 5 carbons. 5 times 2. This is the 2-pentene. So when you start drawing isomers, you need to start in order. First, you start moving the double bond to create like 2-pentene, 1-pentene, 3-pentene. So these are simply 2 isomers that I did. So 1, 2, 3, 4, and 5. Here the double bond is on the second. I'm gonna create a double bond on the first. So that makes it 1-pentene. They want 4 isomers. So 1 is done. Another isomer, instead of having 1-pentene and 2-pentene, let me try the 3-pentene. But is the 3-pentene correct? You will see when I draw it. So what if we put the double bond on the third? 1, 2, 3. In this case, this is not 3-pentene, because when I want to count the carbons, I will start from the side that is closer to the double bond. So it is 1, 2. So there is no 3-pentene. So now in this case, let's start creating branches to create more isomers. So instead of taking 5 carbons as a main chain, let's take 4 carbons as a main chain with 1 branch. So here's the branch. I can do an isomer with a double bond on the first carbon and a branch on the second carbon, or 4 carbons where I have the branch on the where I have the double bond on the first carbon and the branch on the third. Or one more option, 1, 2, 3, 4, double bond here and the branch over here. It's the same if I put the branch also over here. It's the same numbering. So let's fill it with hydrogens. hydrogen. Here 3. Here this carbon, no more hydrogens. Here 1 more, and that's 3. So to name this one, I would say butene on the first and the methyl on the second, whereas this one is butene on the first and the branch on the third. So 2-methyl 1-butene is different than 3-methyl 1-butene. And for this one, 1, 2. So I have a butene on the second and the branch on the second. So 2-methyl 2-butene. So these are 4 possible isomers. They can't, you cannot make more branches with the 3 carbons because there's a double bond and 2 branches, so it's not possible. Now 1-hexene, the larger the main carbon chain, the more choices of making isomers. So hexene is a branch of 6 carbons. So the main formula, the general formula is C6H12. So 1-hexene is double bond on the first, 1, 2, 3, 4, 5, 6. This is 1-hexene given in the question. So they want 4 isomers to this one. So I'm not going to count this as an isomer because they want 4 isomers to what I'm drawing right now. So the first isomer, I'm gonna take the double bond and move it from the first carbon to the second carbon. 1, 2, 3, 4, 5, 6. So instead of drawing 1-hexene, this is going to be 2-hexene. These are the hydrogens. Now, instead of 2-hexene, I can do 3-hexene. 1, 2, 3, 4, 5, 6. That is 3-hexene. The rest of the bonds are single bonds. Now let's make a smaller chain, a chain of 5 carbons. Still need 2 more branches. So a chain of 5 carbons with branches. So let's start with pent. 1, 2, 3, 1, 2, 3, 4, 5. I'll put the double bond on the first. The rest of the bonds are single, and I will make a branch on this carbon. Or I can do 5 carbons, 1, 2, 3, 4, 5, with a branch with a double bond on the first, but the branch is on the third. Or for example, the other choices in the answer key. Or I can make a double bond on the second and a branch over here. There are a lot of options when I have a larger carbon chain. So I am placing the hydrogens . So I gave here 5 isomers. And in the answer key, there are other answers which are correct as well. Because in hexene, I can do a lot of isomers. So I am giving you more options. I'll now start naming these isomers. Uh, the main chain here is is one pentene with a branch on the second carbon. In this one, I have one pentene and a branch on the third carbon, 3-methyl, 1-pentene. This one, I have 2-pentene, so 2-pentene, and a branch on the third carbon. So as you can see, I don't have the same name. Even the examples given in the answer key of the focused question are different. Now subtopic 3.5, this is where we started talking about benzene ring. So benzene ring can be drawn in 3 different ways. I can do this one. This is a correct benzene ring. Or I can do this one, or like that. This is also a benzene ring. Or B. B is also a form of benzene ring. Now these two structures are resonance structure. It means these are 2 correct Lewis structures for benzene. And instead of drawing these 2 structures, we can summarize them in one ring with a circle inside, meaning that I have 6 moving electrons inside this ring because of the 3 double bonds. It's too much unstable, so the electrons will keep on rotating. Anyway, in the question they want to know all of the following are correct structural isomers for benzene except the last one. This is not correct, 1 double bond is missing. Now, what's the difference between aromatic and aliphatic compounds? Aliphatic compounds are the compounds that do not have benzene ring. Aromatic compounds are the ones that have benzene ring. So, a structural characteristic, it will contain at least 1 benzene ring. Could be more, but we need at least 1 ring. Aliphatic compounds, it doesn't have no benzene ring in the structure. It could be cyclic, like a normal cycle with double bonds, like this one is a cyclic alkene. It has 2 double bonds, but it's not benzene. So no benzene ring in the structure. It could be alkane or cycloalkane. It could be alkene or cycloalkene, or alkyne or a cycloalkyne. But there is no benzene ring. It can also have branches as well. Now in terms of reactivity, benzene ring, they're not reactive a lot. So if I want to compare the reactivity of aromatic and aliphatic compound, I would say that aliphatic are more reactive and those are less reactive, because it's very unlikely to break a benzene ring. Now, how aromatic, again another question, how aromatic hydrocarbons differ from aliphatic hydrocarbons? Again, aromatic, they contain benzene ring. These are the aromatic compounds, has benzene ring, whereas the other one do not have benzene ring, and they can both have branches. Now moving on to the next subtopic, the subtopic of the functional groups. Since this table is given in the focused questions, it means expect a question in the exam where they give you a table and they start asking you to name either the family or the functional group. I do not expect these questions to have minimum 10 marks to 12 marks at least if they are coming in the exam. And I'm telling you, it will come in the exam. So when I see OH group, this belongs to the family of alcohols, and the name of this functional group, is hydroxyl. Now, ether, the name of a functional group is ether, and the family is also ether. And ether is an oxygen atom surrounded by carbon chain. You can draw C or you can draw R. R means a carbon chain. And we can write R prime because it doesn't have to be the same number of carbons from each side. When I see atom N, this is an amino group, amino functional group. And the family, this belongs to amines. And in the lesson of acids and bases, anything related to amines is basic. If it's neutral, it is basic. Now, aldehyde and ketones, they both have the C double bond O functional group. Now, this C double bond O, if it's the last one in the carbon chain, we are talking about an aldehyde. So from here I have other carbons. If this C double bond O is surrounded by carbons from both sides, we are talking about a ketone. It belongs to the family of ketone. But both of them are carbonyl. This is a carbonyl functional group. The C double bond O is a carbonyl. Now, carboxyl belongs to the family of carboxylic acids, and here we have a carbonyl group and a hydroxyl group. So a carbonyl and a hydroxyl functional group on that carbon. Ester, also the family name is ester, which is nice to memorize, it's easy. Amide as well, it is. The family name is also amide. Now ester, I have a C double bond O. You studied esters and we talked about them, saying that these are the compounds with fragrances. They have a nice odor. So from one side I have an oxygen bonded to more carbon atoms, and here also the carbon is bonded to another carbon atom, or I can simply write R and R prime. Amide, it's a C double bond O connected directly to an N group. Now this N can be bonded to carbons and can be bonded to hydrogens. So I'm gonna write R like that. Or I can simply leave it without drawing the R. Now next, write the name of the family. Again, this is the same question but given in a different way. Write the name of the family, not the functional group. Be careful. If they ask for family, you have to put family. If you put the name of the functional group, you will not get the mark. So, and we need to complete the missing data in the table. Type formed when hydroxyl OH group replace one or more hydrogen atom in a hydrocarbon example. So what is the family? This is an alcohol. When I have a hydroxyl group replacing a hydrogen. Now what I look at here is a carboxylic acid. It says formed when a carboxyl group COOH is substituted for one hydrogen atom attached to a carbon atom. Example, so carboxylic acid is a substituted hydrocarbon with C double bond OO. C double bond O. Here's the second O and another carbon. This is an ester. So here I have an ester. The organic compound containing N is the amine. Be careful, not amino. Amino is the name of the functional group. And the functional group here is thiol, and also the family name of sulfur containing compounds is also family thiol. Which of the following is a carboxyl group? This is an amino, this is a thiol, this is a carboxyl, this is a hydroxyl. Here you need to memorize the groups. Again, which one is a hydroxyl group? Which one is thiol? Okay, moving on. Compare and contrast between alkyl halide and aryl halide. First of all, to be a halide, it must contain one halogen, at least one halogen atom in the formula, or bonded to the carbon. A halogen could be an atom of fluorine or chlorine, bromine or iodine. These are the elements of group 17. Okay, so now alkyl halide, it's a halogen atom bonded to an aliphatic carbon chain. Whereas aryl halides, I have a halogen atom bonded to an aromatic compound, a compound containing benzene. I need to see a benzene ring. So for example, here I see a benzene. So these two examples are aromatic compounds. Now it's an aryl halide because it contains Cl, which is a halogen, or Br. So this is aryl halide. The rest is a aliphatic chain of carbons. So alkyl halide. So be careful whenever you have a normal carbon chain with an element of group 17, like F or Br or Cl or I, just one, no need to have more, it will be an alkyl halide. If there is a benzene ring, this is a benzene ring, it will be an aryl halide. Moving on, an alcohol is an organic compound in which again, hydroxyl OH group replaces a hydrogen of a hydrocarbon. Okay, now, since this is a question given in the focused questions, maybe they will make changes in the end of term exam. So let's see. If I want the answer to be a halogen, the question must be here. An alkyl halide is an organic compound in which a halogen replaces a hydrogen of a hydrocarbon. So like that, I'll choose option A. If I want to choose option C, the question must be an amine instead of saying an alcohol. An amine is an organic compound in which an amino group replaces a hydrogen. If I want the answer to be D, here they should write an ether instead of saying an alcohol. An ether is an organic compound in which an oxygen atom, but here we cannot say replace hydrogen. An oxygen atom is placed between two carbons. Like that, I can answer D. Next question. Use the following structures to identify the letter that fits each of the following. Alcohol, classification of alcohols, primary, secondary, and tertiary. Again, I remind you, when you want to classify an alcohol, you need to look for the OH group. And then you need to check the carbon holding this OH group. If this carbon does not have hydrogens on it, or if this carbon is connected to 3 other carbons, 1, 2, 3, then this is a tertiary alcohol. If this carbon is connected to 2 other carbons, or it's holding 1 hydrogen, so this carbon holding the OH, it is connected to 2 carbons, so that's a secondary. Or you simply count the hydrogen. You count 1 hydrogen, you say secondary. So secondary is R. Now if this carbon is bonded to 1 carbon only, the carbon holding the OH is bonded to 1 carbon, it is primary. Or you can count the hydrogens on it. So here I'm counting 2 hydrogens, 2, you say 1 primary. Next, symmetrical and asymmetrical ethers. So again, symmetrical or surrounded by the same groups from left and right. So that means this is a symmetrical ether. If the groups from left and right are different, then we're talking about an asymmetrical ether. Here the question, this is an ether, and specifically this is a methyl ether, or I can also name it dimethyl ether. Only in symmetrical ethers it is possible not to write the di, or if you write it, it's fine. Now the following compound also again is an ether, but this time this ether is not the same from the left and right side, so we are talking about an asymmetrical ether. Moving on with the questions. Name alcohol, name the below compound. So I am having here a main chain of 2 carbons, so that's an ethane. Now since this is an alcohol, it's going to be ethanol. There's no need to say 1 ethanol because I only have 2 carbons. Yani I'm going to place the hydroxyl on one of them. The next, we are dealing with 3 carbon chain. It's a propan. Now this is an alcohol. I would write propanol, and this is 1 propanol to indicate that the OH group is on the side and not in the middle. In the answer key is just written propanol. It should be 1 propanol. Now this is an ether, and in ether we name each side separately. Like this is an ethyl, and we place them in the correct alphabetical order. This is ethyl, and over here is methyl ether. Again, this is another ether. I have a propyl from one side and a methyl from the other side, except that M comes first in the alphabetical order. So the name is methyl propyl ether. There are video tutorials on the naming. You can go back to them and study and watch the video to refresh your memory about the naming. Now, next question. Consider the two compounds mentioned below. Do not get confused if you get a molar mass. This is just to give you unnecessary data, not needed, just to distract the students. However, this is an ether and this is an alcohol. This is containing an ether functional group. This one contains a hydroxyl functional group. So first, name compound A. This is a dimethyl ether or simply methyl ether. So dimethyl ether or simply methyl ether. Compound B, this is an ethanol. Which compound have high boiling point? Usually alcohols, they have high boiling point, higher than ethers, because of the alcohols, they contain the hydroxyl group, and the presence of this hydroxyl group, the OH group, allows alcohol to make hydrogen bonds, which elevates their boiling point. It makes it harder or requires more energy to break the alcohol compounds, molecules, away from each other and evaporate the alcohol. So the higher boiling point goes for compound B, because compound B has OH in it that allows it to make hydrogen bonds. Now, volatility and boiling point are opposite to each other. If a compound has an elevated boiling point, it will take more time for this compound to evaporate. So we say it is less volatile. But if a compound has a low boiling point, it will evaporate faster. It means it is more volatile. So this is for A. Analyze based on their structure which compound is more water soluble. Actually, both of them are water soluble, except that alcohol is more water soluble, because you have to mention all the reasons. So, first of all, alcohol is more soluble than ether for the reason it has OH group in it, in the structure, which makes it more polar. Here we don't have to mention, we do mention it. So it has a OH group in the structure, which makes it more polar than ether, and more soluble. So it will be more soluble in water, since water is also polar, and the ability to make hydrogen bonds allows it to be also more soluble in water. Okay, so more soluble in water also because it makes hydrogen bonds between its molecules and with water molecule So it can make hydrogen bonds between each other and with the water molecule. Classify the following as primary, secondary, and tertiary amines. Here's the N. You count how many carbon atoms are bonded to this N. 3 carbons, tertiary amine. 2 carbons secondary, 1 carbon primary. Or you can simply count how many hydrogens on it. 2 hydrogens on the end, 2 for 1, so you say primary. 1 hydrogen, 1 for 2, you say secondary. No hydrogens, you say tertiary. Compare and contrast aldehyde and ketones. Aldehyde and ketones, they are both polar compounds. They both contain the same functional group, which is the carbonyl group, except that aldehyde, they have their carbonyl group on the side of the chain, whereas the ketone, they have their carbonyl group in the middle or surrounded by 2 other carbons. Both of these compounds are polar. Both of them can make hydrogen bonds with water molecules, but they cannot make hydrogen bonds between their molecules. And they are also polar, I think I mentioned that, and water soluble. So aldehyde so common points: contain carbonyl group, functional group. Carbonyl functional group. Both are polar, both are water soluble, and both of them can form hydrogen bonds with water molecules, but not among their molecules. Okay? Now, the difference is that aldehyde have their carbonyl group on the side of the chain, at the end of the chain or at the beginning of the chain. So this C double bond O will be having 1 hydrogen and carbon from other sides, whereas ketones have their carbonyl group between 2 other carbons, bonded to 2 carbons from the sides. So this is the C double bond O. There's carbon from here and carbon from here. Could be more than 1 carbon, but at least a carbon and not a hydrogen like the aldehyde. Now let me put this up in here. Okay, the following letters represent the formula of different organic compounds. So when you have questions like this, before you start answering, I advise you to spread and show the bonds, draw the molecule. Like here I have CH3, and there's a C. Now there's an O. I'll give you options. If you put the O like this, then the formula is wrong. Because if it is an ether, I should see 2 hydrogens on this carbon. Now, since there are no written hydrogens in this formula, then this is a C double bond O like that. C can no longer have hydrogens on it. So that's a ketone, carbonyl functional group. Again, look at this example, CH3 and then CH2. There is O, there is no double bond O here, because if there's a double bond O, it means no hydrogens on this carbon. So this is an ether. This one, There's a big difference if they write COH or CHO. COH is an alcohol because the H is bonded to the O. Whereas in this one, since H is written first, it means that the hydrogen is bonded to carbon. So CH3, CH2, I'm done here. And there's C. There's H on it and there's O. So that is an aldehyde. And last, CH3, CH2. And I have a C. OO, it means that one is a double bond O and the other one continues with a chain. That's an ester. And the last one, you see I have an OH and a double bond O over here. So it is CH3, CH2, CH2. I wrote them. C double bond O, OH. That's a carboxylic acid. So ester, D, aldehyde, C, ketone, A, acids is the carboxylic acid. Which of the following is true about ketones? Ketones, polar. Also aldehyde are polar. So this works for aldehyde as well. They're polar and they do contain a carbonyl group bonded to two other carbon atoms. Yes, this is correct for ketones, but I cannot say that to an aldehyde. So it is 1 and 3. Next, the compound below represents an ester. I have a C double bond O bonded to oxygen. That's an ester. Again, I remind you, to be an ether, if I want to choose option B, I should not see this double bond here. And I will have hydrogens on carbon to answer choice B. If the answer must be a C, this should be a hydrogen. Like that, I will answer C. If the answer must be D, carboxylic acid, we should have H over here. So I'm giving you all the possible options that might come in the exam because they might give the same question but change the formula, the given compound. So this is an ester. What is the name of the compound with the formula below? I have a carbonyl group, that's a ketone. Now here they're giving me anon. And 1, 2, 3, 4, that's a butanone exactly on the second. That's it. Butanol should look like that. Let me draw butanol. So here's the answer. Drawing butanol, 1, 2, 3, 4. That's a butanol. Ethyl, methyl ether, that's O. Ethyl from one side. Methyl from one side and ethyl from the other side. Pentene is just 5 carbons, 1, 2, 3, 4, 5, but they did not tell me where's the double bond. It could be on the first or it could be on the second. Anyway, I'm telling you again, this is a multiple choice question. They can give me correct choices, real compounds or compounds named in a wrong way. So you should not answer D. D is a wrong choice. Which of the following is or correct about aldehydes and ketones? Aldehydes and ketones, they are polar. They contain carbonyl group. Aldehyde contain carboxyl. Stop, this is wrong. They can form hydrogen bonds, yes. Oh, not with themselves. They can form hydrogen bonds with water only, not between their molecules. Consider the below compounds U and V. Okay, again, this is a ketone, and this is an aldehyde. These are isomers because they are made up of 3 carbons each. So to which family U belongs? To ketone. To which family the V? To aldehyde. This is a question that came in the end of term exam last year. I am also placing on Teams previous exams, the exams of last year and few years back. Polarity, both of them are polar. Now these are the definitions of some other compounds. On the line before each statement, write letter K to N of the compound that best fits each statement. So, an organic compound which acts as a proton donor, this is something that we saw in topic 6, acid and bases. Bronsted acid, that's K. This compound is soluble in water. All of them basically are soluble, but contains a carbonyl group between 2 other carbons. That's a ketone. A compound, nice smelling organic compound, we're talking about esters. And an organic compound with a carbonyl functional group bonded to a hydrogen, that's the aldehyde. Next, complete the table with the IUPAC name of the compounds below. So be careful to the termination. This is an aldehyde. The name must end with anal. This is carboxylic acid. The name must end with anoic acid. Also this one, anoic acid. Now let's name the main chain. I have 2 carbons main chain. It's an ethanol. I have also 2 carbon ethanoic acid, and here I have 3 carbons propanoic acid. Define, okay, now topic 5. Define a reversible reaction. Reversible reaction is a reaction that can go in both directions. It's a reaction written with this symbol. It means that reactants gives products, and once their amount is enough and the products can give back the reactants. It's a reversible reaction. Like A gives B, but B again can give A. So we say that this is a reaction that can go in 2 directions, forward and backward. Take characteristics of chemical reactions that reaches equilibrium. To reach equilibrium, they must be reversible. To reach equilibrium, the system must be closed. To reach equilibrium, the conditions of the experiment or of the reaction must be constant, and reactants and products must be present. So it's a reaction that goes in both directions. I need the product and reactants to be present, and we insist on saying that it is a closed system, because imagine that you have oxygen gas forming and it is open. In this way you are going to lose the oxygen gas. That's why sentence number 2 is a valid sentence. Reactants and products should be present. So if it's a gas, the gas should not escape the system. We should keep it in the system so that the system can reach equilibrium. The rate of the forward reaction is equal to the rate of the reverse reaction, and the concentration of reactants and products must be constant. So 1, 2, and 3. Next question. Here, when they ask you to write the K equilibrium, be careful if the system is homogeneous equilibrium or heterogeneous equilibrium. In heterogeneous equilibrium, anything liquid or solid not allowed to be written in the K equilibrium formula. Now, whatever number that we see here, these are power. It will be to the power of the number. So Kc, or also K equilibrium, is NO2 squared over N2O4. You must place the formula between brackets because these brackets represent concentration. It's the symbol of concentration. Any concentration is represented by this symbol. Now Kc here is equal to S2 multiplied by H2 squared over H2S squared. The next Kc is equal to H2O multiplied by CH4 gas over hydrogen cube multiplied by carbon monoxide gas. Everything in brackets. The number that you see over here, I write them to the power of that number. So here Kc is equal to NO H2O to the power of 6, O2 to the power of 5, and NH3 to the power of 4. Kc, hydrogen to the power of 4, CS2 multiplied divided by the concentration of H2S squared multiplied by the concentration of CH4. Now, for heterogeneous equilibrium, we do not include the solid in the formula of Kc or Kp, whatever we are writing. So here they want Kp, and note that if you are writing Kp, you are not allowed to use brackets or parentheses. It is wrong. You should put the letter, the symbol P, like pressure of the gas itself. So here, pressure of C10H8. I'm not gonna say divide by C10H8 solid because it is solid. So simply like that. Kp is only pressure of CO2. Kp is pressure of hydrogen multiplied by pressure of carbon monoxide divided by the pressure of water. And last one, pressure of CO2 over pressure of carbon monoxide. Moving on with the questions. Are the reactions in the table representing homogeneous or heterogeneous equilibria? Here, heterogeneous equilibria. But this table here, homogeneous, because everything here have this, like here, same physical state, all gases. So here, homogeneous equilibria. Down here, heterogeneous equilibrium. Calculate the value of Kc for the equilibrium constant expression given concentration data at one equilibrium position. So first of all, we need to write the formula of Kc before substituting. So here's the equation. NH3 squared H2 and N2. So NH3, be careful when you do the calculations if there are like concentration raised to a certain power, not to forget this in your calculator. Here's hydrogen 1.6 cube, and here's nitrogen. So after plugging this into your calculator, it is 0.4. What is true about K equilibrium? Simply K equilibrium greater than 1, it means products are favored and reaction going in the forward direction. Like that. Now if K is less than 1, it means that reactants are favored and reaction going in the reverse direction. Now next, Le Chatelier's principle. These questions will ask you to answer whether left or right the equilibrium will shift. And if you're not answering left or right, you are probably answering by the color. Now before we start, here there's a delta H positive. It means that heat is added with the reactants. It's an endothermic reaction. So using your knowledge on Le Chatelier's principle and based on the information above, predict the color of the mixture when it is subjected separately to each of the following stresses. Cl minus, we are adding Cl. Whenever I add Cl, the equilibrium will shift forward toward the blue direction to remove what was added from Cl minus. Now add a few drops of cobalt hexahydrate ion, which is this one. So adding few drops will take also the equilibrium forward toward the blue side. Now adding few drops of cobalt tetrachloride ion, which is this one, will take the equilibrium backward towards the pink in order to re-establish equilibrium. How decreasing the volume? Immediately when you read the word decreasing the volume, directly in your head convert it to increasing. Pressure. And whenever they give you questions of volume and pressure, you need to count the moles on the equation. So I have 2 versus 3. And here I have 2 versus 2. So in the second one, no matter what you do, whether you increase or decrease the volume, increase or decrease the pressure, it has no effect on equilibrium. So no shift. For the first one, decreasing volume, it means increasing pressure. So the equilibrium will shift to the side that has less molecules, and that is towards the right. Again here, this question can come brown and colorless, by the way, okay? Because the N2O4 is brown, NO2 is brown and 2O4 is colorless. Anyway, if N2O4 is added, equilibrium will go toward the right. Again, if NO2 is removed, we are removing from here. So, equilibrium will go in this direction to give back what was removed, also to the right. Pressure is increased, so I need to count 1 versus 2 mole. If pressure increased, equilibrium will go towards the side that has less molecules of gas, which is to the left. And volume increased, meaning pressure decreased. If pressure increased, equilibrium went to the left. Therefore, if pressure decreased, it is going to the right. You already have the result of this one. Now, moving on to the last question in topic 5.3. They will give you values for the concentration. You need to substitute in the formula of Kc and find the answer. So the Kc of this compound is NOCl, NO2Cl raised to the stoichiometric coefficient power over Cl2 multiplied by NO2 squared. So the answer is going to be 0.500 squared over 0.320 and 0.250 squared. So the answer is going to be 12.5. List common properties of acids and base in solutions: bitter, slippery, sour. pH above 7, OH minus is the dominating ion, pH less than 7, H plus is the ion present, it's the dominating ion. They both conduct electricity because they have ions. They both can react with each other. Only acid reacts with metal, and react with carbonated metals. It can also, I mentioned it, react with metal. What else? Litmus paper changes litmus paper to red. And changes methyl orange also to red, colorless with phenolphthalein. For the base, they don't react with metals, they don't react with carbonated metals. They change the litmus paper to blue and they conduct electricity. They change the phenolphthalein color to pink, purple, and methyl orange to yellow. Base, they have bitter taste. Remember this property. In this lesson, they are only going to ask you about the properties. So here, type of solutions in acidic, H plus concentration, see the symbol, concentration is more than the hydroxide ion concentration. In basic, it's the OH minus that is dominant, that is more than the H plus. And in neutral, both of them are exactly equal. So it's a neutral solution. Classify the following as binary or oxyacid. Binary, oxyacid. Oxyacid is the acid that can contain oxygen. So H2SO4 is oxyacid. The rest are binary because they do not contain atom oxygen. Now phosphoric acid, H3PO4, diprotic, no, it has 3 hydrogens. Triprotic, oxyacid. Okay, it contains O, so it is 2 and 4. And that's it. Thank you for listening and good luck in your exam.